Okay, suppose we want to simplify this. You might say, wait a second, what's this weird symbol? That's just an H. Why am I using H? Why not use Y? I'm told to simplify this. Well, I'm using H because this is actually a difference quotient. Let's insist that H is not equal to 0. So I'm only considering values of X and H where H is non-zero. That's good, because if H was 0, I'd run into a problem right there. Okay, so this is something that you're actually going to see later on as we move forward in mathematics. Difference quotients come up a lot. This is an example of a difference quotient. Without going into details, I'll just say this is something that shows up a lot later. So I want to simplify this. The radicals are already in the numerator. And if I multiply by a conjugate, I might move them into the denominator, but that's not necessarily a bad thing. Let's try multiplying by the conjugate. I mean, we're not being asked to rationalize. We're not being asked to move radicals out of the denominator. We're just being asked to simplify. And whenever you see a sum or a difference of roots, multiplying by the conjugate is not a bad thing to consider, at least. I'd always consider it. And of course, I only wanted to multiply the top, but I can't just multiply the top. That would change the problem. So what I'm doing here is I'm multiplying by 1. In any case, this product gives me x plus h. Then this and this are going to cancel out, because I'm going to have a positive root x times root x plus h, and a negative root x times root x plus h. And then I have these two. I get minus x, because that's minus root x times root x, over h times the root of x plus h, plus the root of x. Now, what do I have? I have x plus h minus x in the top. Those x's go away, because x minus x is 0. And then I can cancel that and get 1 over the root x plus h plus root x. And is this any simpler than what I started with? Well, in a way it is. I mean, we had a root x plus h minus root x over h. We had something non-1 in the top and the bottom. 1 is definitely a little simpler than having a variable there. And this is about the same level of difficulty as that to stare at, or discomfort to stare at. So I think we've simplified this nicely. Some of you may have an issue. When I canceled this x and this x, I said the x minus x is 0, so I get nothing and I don't have to think about them anymore. But when I canceled this h and this h, I didn't get 0. What happened here? Well, one of these is an additive cancel. Whenever I take a number and I add its negative, I get 0. But when I'm canceling this h and this h, what I'm really doing is I'm sort of multiplying the top by 1 over h. And those cancel. H times 1 over h gives me 1. H times 1 over h gives me 1. And any sort of multiplicative cancel gives me 1. Some of you might have an objection. What happens if h is 0? Well, this statement's going to be true. This is equal to this in the domain we're looking, because we said that h is not equal to 0. So we're only looking in situations where h is non-zero. If we were looking over real numbers, you might have an issue with the fact that this exists when h is 0 and this doesn't. But this was said in the beginning, and these two do differ at one point, because one has a number I can plug in where I can't plug it into the other. But that's fine in this situation, especially since we emphasized at the very start that we're only considering situations where h is not equal to 0. So that's another example of taking conjugates and simplifying expressions with radicals.